Yep. So thank you for staying back. And title I changed a little bit because biomimicry is not a word which is often known. So I would like to introduce you as this one here, that there is nothing more risky that we are doing now if you continue doing business as usual. And I think this stage at the GIZ Sustainability Summit involving technology is a good platform to tell you what we from Biomimicry Germany want to accomplish, and it's basically cooperation. We don't want money, we want people who are interested in doing work where we are aligned with our kind of concepts. So the first question is, who loves to be out in nature? Some of you, yeah, that's great. So this talk is perfect for being out in nature, and if not been, or you'd like to be out in nature, maybe I will motivate you to be more out in nature, because there's a vast amount of solutions out there. And why I think the business as usual is risky is because we have finite resources and we produce infinite waste. Yeah? So this is how it's going. That's the status quo. And this picture won a photography award, and it was like a guy who was snorkeling in Indonesia, and he found that, yeah, with all the plastic we are throwing into the oceans, it kind of gets integrated into our lifestyle. But this is not a normal picture, and this is somehow stunning. The waste we produce often goes unnoticed, but somewhere in the ecosystem it affects some form of life. And WWF, back already in 2012, said like if every one of us lived like an average resident of US, we would need resources from 4 Earths to fulfill our needs for an annual, for a year. But we know that we don't have this opportunity. So I would like to pitch the talk more about resources. And one resource we all know is water. And this is school knowledge, right? So 71% of the Earth is covered by water, where most of it is still salt water, and we don't have really good idea to desalinate. It's very expensive at the moment. Out of this, 97.5% is gone, so we are left with 2.5% fresh water. And this is not even so drastic, because out of this 2.5% fresh water, only 0.3% is fresh drinking water. And at the moment, the population is increasing, so we have this water, this 0.3% water, to almost cater for 7.1 billion people. Now, to put this more in context, if you take a person from Mozambique, would use maybe 4 liters of water per day. But if you go to more developed countries, you see this becomes more of an acute problem, because in China, 86 liters, in Europe, it's already 250 liters for a person a day. And if you go to US, it's like 575 liters of water consumption per day. So that's already a lot. And if you put how many people we are, it kind of becomes exponential, the crisis. If you see for products, to produce a cup of coffee from the time you grow the seeds till it comes on your table, we invest 140 liters of water. If we go for food, it's 11,000. A car, much more. And just to tell you, the next 10 minutes of my talk, we'll have 3,000 billion gallons of water will only be used in Germany. So we are coming to a situation when we do not have enough resources on our planet to continue the way we are doing. And this calls for something which is, we need to change the way we live, we produce, and we consume. This brings in the need for some kind of innovation. Yeah? And when we talk about innovation, what can we do for this kind of problem? We could, on one hand, be responsible in our consumption, and on the other hand, we could reduce waste. And this kind of brings us back to the goals of sustainable development, and number 12 basically points towards this direction: responsible consumption and production. So biomimicry is a creative method where we can learn about sustainable innovation and product design by learning from and about nature. So what is it about nature that we first need to do? The very simple thing is observe. Just observe around you what kind of clever strategies nature has. Even if you see like a simple leaf, it has 2 surfaces on 2 sides, which means that the 2 sides of a leaf can do 2 different functions. Yeah? And this is a really good example of how we can reduce material use but increase functionality. That's what we want to do. But we cannot do this in a man-made way. When you do a table, it has one surface, and if you want another kind of quality or property, you need to use another material. So we do not even understand how a leaf is able to build two different functional surfaces by using very simple strategies. Another example, so a case study, is that we all know, like, there are beautiful butterflies everywhere, even peacocks. Most of the butterflies are colorless. Yeah? So what you see as a very, very bright blue wing is actually reflected light. So it is reflecting sunlight because it has very fine scales, and the color is just the perception we have from the butterfly. It has no toxic pigments to produce colors. This is the science behind it. So if you look at the microscopic level, you will see that there are many scales of organization, and this kind of reflects the light. Now, why is this important? Or what can we learn using biomimicry from this? It's because when you want to deal with colors, we often use pigments, and most pigments are toxic. Yeah? It's not sustainable in a way, but we need this. How can we bring structural coloration into architecture, into product development? Can this be done? So when you see how we can kind of go ahead with biomimicry is to look at beautiful stuff in nature and ask the question why and how. And then you will understand where you can use it. So this is just a way of design process that you see something, you get inspired, and you ask the right questions, and you put a context to it. So what has been done from these examples is that they developed a screen, and as we know, like most of our displays consume the maximum energy. So these screens, these display screens from Mirasol are based on the principles of a butterfly wing or structural coloration. And what results is that you can read this any kind of light atmosphere, so directly in sunlight or in the darkness, because since it's reflecting the ambient light, it automatically adjusts to this. And this, of course, then consumes much less energy. So you don't have to worry about recharging your iPhone every day, or once you charge this kind of displays, it runs without a problem for up to a week. So this could solve a lot of the energy demands we have on our electronic gadgets. Another example, to go back a bit in history, was about this bullet trains in Japan. And they were not called bullet trains because they were fast. They were called bullet trains because Japan is a country where there are lots of tunnels in the mountains, and whenever the train went in and came out, it kind of broke two surfaces and made a lot of noise. So initially, the Japanese trains used to look like that. And this guy, he was quite high up in the ladder in Japanese railway, but he was also a nature observer. So to solve the problem of unhappy Japanese, what he wanted to do is he wanted to solve this problem. So how can we make people happy in the nearby villages when this train is going at a high speed and making such a loud noise? And he kind of looked into nature because he was a bird watcher, and he saw that this kingfisher does this every day. Otherwise, it will kind of die of hunger. It has to go from air to water. It catches the fish just under the water without making a splash or a loud noise, because then the fish will run away. So then they studied the mechanics of this, right? So it's not only like copying it, but you understand the physics and the mechanics behind it. And then they developed the new form of trains, which we are all used to everywhere in Europe. And this is the way the train is designed nowadays. And this is the new, the new series of the Shinkansen trains in Japan. So this is a very popular story about bio-inspiration and how you can bring it into practice. But the thing about biomimicry is that evolutionary designs are in nature sustainable, and evolutionary designs are based on natural principles. So the main problem was, the main challenge was to reduce noise. But what happened was you get collateral benefits. You reduce the power use, you enable faster speeds, you lower the prices per seat that you offer, and you have happy customers. So these kind of the last 4 points were not expected, but it just happened just by solving one of the challenges you have using evolutionary design. So this is like what nature does, and we cannot do that using our man-made capabilities at the moment. We cannot do life-friendly chemistry. For building a house, we need cement. We need to heat this thing to 800 degrees Celsius. Nature doesn't do that. It builds everything at ambient temperature. There's a lot about scalability, locally attuned. If you develop a solution in Germany, it is not locally attuned somewhere in Africa, so you want to have this possibility that it can locally adapt to the climate conditions there. So that is what you can learn or adapt from nature, and these are called life's principles, because unlike us, unlike humans, nature doesn't have the possibility to build a factory at the end of the city where we can pollute as much as we like. Everything is part of nature, right? So this is a constraint to think about innovation in a way that you have the environment as sustainable as possible. So when we talk about biomimicry, the core concepts are all pointed towards sustainability. Think about, when you make a house, think about the design for disassembly. Think about what happens when this house will be taken down. How much waste do we produce? How can we build something when you disassemble that it leaves the least environmental footprints? How can you make closed-loop systems, a circular economy? How can you make it modular and scalable? How can you optimize rather than maximize? Because you don't want to maximize something, you want to optimize it. Maximizing is a human perversion because we want to get most out of something. But nature works on optimization principles. And the last thing is, of course, reduce waste and build more carbon-neutral products. So, Biomimicry Germany, we are based in Berlin, and we consult and offer a platform for companies as well as research entities to integrate these kind of concepts. And we do both a non-profit and profit-oriented part. So we are doing different kinds of training for the trainers, company CEOs, as well as in education. Back to basic school, primary school, universities. So we kind of try to bring this as a method. And yeah, this can only work if we are interdisciplinary. So scientists, analysts, designers, architects, we are a group of people all aligned with the vision of making things better or making things good from the beginning. Because we spend too much time about thinking what exists and to make it better. But think about how can you make it good already from the time you make it or from the beginning. So we have been lucky, and we have worked both with academic institutions, organizations, and companies, and these are some of our projects. So if you are interested, we can have a chat about it later. It's also important to have affiliations in Germany. So if you're bringing in a new method, you have to be kind of aligned with other players who are already there. So you have the German industry norms, and we were part of the biomimetics group, as well as we have a project with the EU to bring this more effectively forward. Now, coming back to the resources water, it's a problem which is already in Europe. So if you look south of Spain in Murcia, they have limited fresh water. And they had droughts. They were buying water on containers on ships which were brought in from France. And this is a huge problem in front of our eyes. But we are not only the first species which kind of face these challenges. Nature does this. Nature knows how to do desalination. So if you see these mangroves all around the tropical belt, they live in salty water, they are natural filters, and they can get the salt out. They have these mechanisms. We do not understand how this works, but we are starting to get there because we are looking a little bit more into nature. In very, very difficult atmosphere, there are also cactus which grows. They have their mechanisms of getting air from the atmosphere. So can we understand that? And how can we use this? So recently, a group of architects used these mangrove towers near very dry zones, like in Spain, and they started building this. Yeah? So you bring this kind of skyscrapers, they're filled with mangroves, they suck up the salty water, they are happy, but in the evening, when they start to condense, this architecture here is able to trap this fresh water which is being condensed, and you can collect it every day. So to give you a number, 100 by 100 square meter of this can give you 3,000 liters of fresh water a day. We don't even have to understand how they work. We just know how to design it. Yeah? So this is the advantage you have when you work with interdisciplinary teams. Another example was derived from this cactus plant, and in many regions in Africa, including Ethiopia, they build these water towers by enabling the local people. So these are very easy to build, and they are based on this same principle as cactus work to get water a day. And in a place where you don't have any water, or not even like a liter of water easily accessible, 100 liters of fresh water a day can run a family, or even 2 families. So we kind of start appreciating what we can do and also locally enable people to set these solutions or implement these solutions. We, for ourselves, have some project about this water crisis, which is going on at the moment in relation to oceans. So first, we partnered with Fraunhofer and a cruise building company, STX France, because cruises are like little cities, and they do a whole lot of shit to the oceans. So 10 kilometers of the ocean water belongs to a country, and beyond that is international waters. No one is responsible. So what the cruise ship does is they deposit all their waste, gases and other stuff in these high waters where no one is responsible. But this is not sustainable. It's not, since we do not see it, it doesn't bother us, but it is somewhere out there on our planet. So we were working with this company as well as a research institute to develop algal photobioreactors because they can purify gray water. You can make a closed-loop system. They can give you energy as well as biomass and biodiesel, but this research is ongoing. So at the moment, we could say that these kind of photobioreactors can filter gray water, and of course, it's not drinking water then, but you can use it for a lot of other purposes on a cruise ship. And this already, like small steps, makes a big impact if you see the scale of this issue. And we have been lucky to work with some other, both academic and industrial partners. And this is like from our work, what we have done. I don't have time to get into each of the projects right now. But what is interesting is how many people are interested in this method and to develop from all parts of, from all kinds of profession, all kinds of networks. And there is a large growing network of biomimicry networks pretty much all over EU. And there are a couple of strong networks in South America and Asia. So I'm happy that if any of you are interested in this kind of work and what could it mean, and if there are any local parts, local players in the parts you come from, and then we are happy to connect you with them. So I would leave you with this, and I guess my time is over. So if you have any questions, please feel free to join me in Glasshouse, and I can tell you a bit more about how to bring this in. Thank you.